Okay, so welcome to the channel. My name is Victor, and I'm going to be your anchor for this training. So this is the CompTIA A Plus 2 core-based exams, the Core 1 and the Core 2. The curriculum for the Core 1 is the 220-1001, which covers mobile networking, hardware virtualization and cloud computing, hardware and network troubleshooting. Whereas 220-1002 covers operating system, security, software troubleshooting, and operational procedures. Now, virtualization is a portion of the exam content, and in this part 6, we're going to be looking at virtualization and cloud computing. Now, the idea is that whether you want to do DevOps, whether you want to do cybersecurity, whether you want to do go core into cloud computing, or whether you want to do cybersecurity, these are very fundamental things you need to understand, you need to know. Why do we need to virtualize? What are some of the basics of cloud computing? So in the CompTIA A Plus certification, you need to understand. So you don't need a technical know-how here. That's why the objective says summarize. So you see in some of the, what's it called? In some of the objectives of the exam, you're going to be told to be able to troubleshoot. Some of the objectives of the exam, you're going to be told to fix or to solve or to try to get to a particular result to solve a problem. But in some of the objectives, you are told to summarize. That means that this is for knowledge sake. This is for you to be able to understand the concept. Right? If you are not doing a cloud computing or you're doing a core cybersecurity certification, then this is now going to come very, very handy. So it doesn't make sense for somebody that's going to be an IT technician not to understand virtualization. So virtualization is just a process where it's going to be possible for you to run more than one environment in a device. Take, for instance, you have a Windows computer. It then means that you can run an iOS, you can run Android, you can run Linux, you can run several operating systems within one system. That's what virtualization helps to achieve. So, and especially if you want to create a sandbox, if you want to create like a testing ground, if you want to do some kind of, maybe do pen testing, or you want to do some initialization to better understand some kind of environment, some software, some application, virtualization comes handy. Now, for cloud computing, on the other hand, when we say cloud computing, we're trying to say, put in simple terms, every other thing or anything we can do offline, can we be able to do that online? So is it storage, hard drives, and the rest? Is it web applications, maybe hosting them on a physical server? Is it, let's say, compute, that is having processor speed and all of those hardwares? Is it mobile applications, having them maybe regularly on regular servers? Can we now push them, like the cloud would normally say, the internet? So it gives us advantage of scale. So we can be able to do something that has huge, what's it called? Our space is not so limited. Right. Compared to if I need to take, for instance, store 1 terabyte. It then means that once I have a 1 terabyte computer, I cannot go more than 1 terabyte until I go and acquire, configure, and install that 1 terabyte, additional 1 terabyte, or I will remove the 1 terabyte and fix in a 2 terabyte hard disk. But in cloud computing, it gives us advantage of scale, right? So we can easily upgrade or scale our devices in terms of storage, as an example, to 2, 3, 4, 5 terabytes, and even in quote, limitless opportunities. They are possible because you have the internet, you have very, very huge servers that can serve those purposes. Or is it processor speed? If I need to have maybe an application and I now have people like accessing it a lot, and it's a physical server I have, what's going to happen is that once there is a surge in traffic or a surge in requests, that my server is going to be down. But if I explore cloud computing, that means that I can scale up my processor speed, I can scale up my bandwidth, I can scale up those things easily, or I can even build a system this is not me talking about cloud computing. So this is the job of the cloud architect. He can plan and scale once there is need to scale without any interference from the cloud engineer or the cloud architect. So these are some of the things you need to have basic understanding about. So if you're going to go into cybersecurity, if you're going to go into cloud engineering, then this is a good foundation to be able to understand. But for now, our interest is that we want to be able to summarize cloud computing concept. Then we're able to want to summarize aspects of client-side virtualization. Now they say client-side, it then means virtualizing on my own system. Take for instance, I have my VMware here. This VM now is hosting my Kali Linux machine and is holding my Black Axe Linux machine. I could do Windows XP, I could do Windows 7, I could do Windows 10, I could do a Metasploitable, I could do, what's it called, Android, I could do iOS, Mac. I could do as much operating systems as possible. This is what virtualization, right? So we're going to be explaining this concept as we move on. So if you're new to the channel, don't forget to subscribe. This is a complete series. We'll see how far we're going to go. And if you have questions, you can always ask. Mr. James on the call. So if you have questions as I'm going through, you can just ask. Now, cloud computing involves using remote servers. It then means a server is just a computer that is going to deliver either information. It can be a file server, it can be a web server, it can be an email server, it can be any type of function, right? But it's not now with you. It is where? Somewhere. Where is that somewhere? Maybe a hosting company, a cloud provider has that system. It's not something that is supernatural. No, it's actually a system somewhere that you can readily access over the internet. What are the things that cloud computing will help us do? Storage, manage, process data. Instead of using what? Local servers or personal computers like I explained. So don't forget that computers is made up of hardware components that process software instructions. So this is one hardware machine running several virtual servers, right? So you have email server, print server, file server, group server, application server, database server, right? Okay, this is the part where you get to answer some questions to test your knowledge if you understand the concept we have in this material. So I'll just move straight to the content. Now, foundation topics, cloud models. So we're trying to say, how do we model the cloud? So cloud refers to any type of computing, including programming, execution, storage, or services. It takes place remotely. Understanding basic cloud concept is important for technicians, right? Who will increasingly be asked to manage a software or data in the cloud. Normally, you should have a cloud computing training or certification, especially if you do that. But it doesn't hurt to have an understanding. It doesn't hurt. With AWS platform, with Azure platform by Microsoft, you can easily set up a free account and test some of these things. Test, maybe have a small site, test it and host it, right? Have a small application, test it and host it. Have a small, let's say Amazon S3, you have a free tier, that is a service that is free with their limits. Then you could set it up and host your application free. So with this gives you an idea about how some of these things operate. Understanding basic cloud concept is very important for technicians. Now, what are the different models? We have IaaS. So we call this infrastructure as a service. So when you say infrastructure in tech, we mean all of the different functions that we will need to deliver IT services. So storage, network, and networking services. It then means that there are companies that offers cloud computing, but they typically deliver it as an infrastructure. It then means that if I need storage, something like Google Drive, pricing. I think they call it OneDrive or so. Right?
Yeah.
So it then means that if I have, I'm in Nigeria now, so if I have 1,000 naira, that's what the price is showing in naira. If you're in the UK, you see it in pounds. If you're in US, you're going to see it in dollars. If you're in Australia, you're going to see it. It just checks your IP and gives you the pricing. So that means that if I have 1,900 naira or 2,000 naira approximately, I could get 2 terabytes. And in 1 year, I just need the 20,000 naira, about $20, $30. I could have 2 terabytes storage. I could share with up to 5 people to have access. I could manage my photos. I could have several features, right? Now, this 2 terabytes is what? Storage. At times we call networking services compute. Then network, I could set up networking in the cloud so that I could assign IP address. If you check a website, if you ping a website, it typically be an IP address. So in this model, the cloud provider covers the cost and work involved in equipment, firewall. There's always what we call the shared responsibility model. Shared responsibility model. If you take any of the foundational cloud computing certification, either AWS cloud practitioner or the the Azure fundamentals, you are going to learn. These are some of the foundational things you're going to learn. It's going to be part of the exams. Who takes responsibility for the different types of cloud model? So let me use this image to explain everything. Just a second. I think I love this one. Oh, no. Okay, I think I love this one. Yes. Not too sharp. I think I love this one. Sharp enough. Awesome. Can you see my screen?
Yeah.
Okay, now. So what we're trying to say is that if you decide to do your middleware, your application, your database, your operating system, your virtualization, your servers, your storage, your network, right? If you want to self-manage it by yourself on premise, you take the entire responsibility.
Yeah.
If you are now doing infrastructure as a service, what will happen is that you self-manage only this part, like the Google Drive I talked about. You still need to have your system. You still need to have all of this stuff, right?
Yeah.
Now, the provider manage, that is Google or AWS, that is Amazon or Alibaba or Google, any of those providers, they will supply all of these other stuffs. Infrastructure as a service. Now, if it is platform as a service, it then means is a provider is supplying almost everything. You just manage the application. Whereas if it is software as a service, take for instance, when you say Google Drive, drive.google.com, let's say /doc. Okay.
Yeah.
Let me go to drive.google.com. Let me see if I can create a new doc, right? I don't need to install anything. So this is an example of software as a service. So this software is given to me as a service. It can be free or I can be paying per subscription. Or you see, let's say an inventory management system that you typically don't do anything. All you do is just make your what's it called? Make your subscription. Everything is taken care of. Just pay your subscription. Once you pay your subscription, the software is given to you. You start using it. So you see, with this, I don't need to, we are learning cloud computing within the CompTIA A+ curriculum, right? So I could save this document, I could send it to somebody, I could even share, I could collaborate, I can do a lot without having to install any software. I just need to be online. So you could say, we could say, let's get to chat GPT, and let us get some little bit of insight very, very swiftly. So I could say different cloud models, their advantages and disadvantages. And also I will need practical examples and platforms or softwares case study. I need the answer in a tabular format, right? It will help you understand some of these grammars I'm speaking about. Okay, now, so you call this public cloud, private cloud. Then we have hybrid cloud, community cloud. This is another way, multi-cloud. Then, okay, so this is one way to categorize them, but I will prefer categorization as PaaS, as platform as a service, infrastructure as a service, SaaS. So I want to classify this particular way. That other way is also a nice way to categorize, because here you are trying to say who is using it, right? So, but here I want it to classify it according to how is the platform built. Okay, awesome. So in the first description, we're saying that public cloud is a model that anybody can use, right? So who are the providers? Amazon Web Services, Windows, that is Microsoft Azure, then GCP, Google. Now, what are some of the case studies of software that use these systems? Netflix uses this system, and several other service providers, they use Amazon Web Services. That's one way they can be able to scale and host thousands of movies, right? That space, you cannot buy that space from a regular hosting service, right? So you will need a cloud service provider. And I always tell my students to go research on how Amazon Web Services started. They are like the #1 when it comes to cloud service services, because of course they are the #1 e-commerce website in the world. Their inventories are in hundreds. Sorry, I think their inventories is in millions. Now, another question now is that who is going to host the person that have the highest or has the largest website? Will you be able to host the person? That means that if you want to host them, that means you need to be bigger than them, right?
Yeah, yeah.
So because of course nobody will be able to host them, they have to now host themselves. So that's why once they solved that problem, they now have to start providing the services to others. And people pay a token. That's why also I love the AWS certifications. I have some of them. Because if you want to take an AWS certification, take for example, if you take practitioner is $100. If you pass the practitioner exam, you want to take architect. Cloud architect is $150. But because you passed the practitioner, you get a coupon on your platform, on your certification platform. You get a coupon that gives you 50% off your subsequent exam. So instead of paying $150, you're not going to be paying $75. Now, if you pass that exam, let's say you want to take architect professional, or you want to take a specialty exam by AWS, that is normally $300. Let's say security specialty, machine learning specialty, or you want to take any of those specialty, which is $300. Because you pass this other one, you get a coupon also, and instead of paying $300, you pay $150. So roughly about $300-400, you can take about 3 exams in AWS if you want to be a cloud engineer, compared to other platforms where you don't get such discounts. And this is to encourage people to learn about their platforms, use their platforms, implement their platforms for individuals and enterprises. Now, this is public cloud because anybody can use it, right? Advantages is cost effective, it's very scalable, no maintenance. Disadvantages, so less control over security, limited customization. This is for each of those providers, right? Then compliance concerns. Private cloud is where you deploy a cloud application or a cloud system only for yourself. So you are going to actually be spending a lot of money. So who are some of the providers? So you have OpenStack. Who are some of the people using that? NASA, IBM Cloud Private, then you have Bank of America using some of these systems. Then which one is hybrid? It then means that you design like a solutions architect. We will be doing the job to implement hybrid cloud. What is it going to be doing? A company have a payment system they want to implement. It's going to be on a server physically and remote. That is what regulation says, that you need to have some sections of your stuff physically, then some sections of your stuff and the backup on remote cloud. So that once anything happens, you can still have backups, you can still have whatever. So that's kind of classical example of hybrid cloud. So if you are familiar with cloud computing, like the purpose of this certification is for you to just have an idea, not necessarily the inner workings of how these things happen, but I just want to do some deeper explanations for you. Like the AWS Outpost, the Azure Hybrid Cloud, the Amazon Athons, these platforms helps you to like connect your physical servers to a remote server so that you can have a kind of hybrid system. Then this one is community, right? So it's kind of shared government corporate kind of system. Then you have multi-cloud, right? So multi-cloud where you are implementing more than one provider. The 3 top providers we have in cloud computing is who? Amazon, they own AWS. Microsoft, they own Azure. Google, they own Google Cloud Compute or computing. So multi-cloud says, can you create a system that is going to implement multiple cloud providers? So this is for scalability. This is for, what's it called? What's the right word again? Redundancy. Redundancy is a concept where you want to make sure that when anything here fails, you can spring up and pull out your second rifle, so to say. So that's one way to classify cloud computing. Another way to classify cloud computing is what you can do. So the first one is what? SaaS, software as a service. So this one, they just give you the software, you pay for it. You don't know anything that is happening underneath. So Salesforce, Dropbox, Slack, even Zoom, that you are paying subscription, is a SaaS application. So that's why software developers, most of the time, they want to transit from deploying applications where people pay only once. Because people paying only once for a software does not give you continuous development opportunities. So you just develop the application, you sell it, and you go to bed. Please, we have an issue. We want to do some features. You paid me last 2 years. You still say I should come and do upgrade on top of. Please, I don't have that time. Or it's not worth the time. So, but SaaS makes it possible that you have an application. The person does not buy it off completely. But rather, what happens? He pays subscription fees, but maybe little subscription fees. So the advantage there is the scale. You can be serving 1 million customers and they are paying $5 per month.
Okay.
So, and it gives you opportunity to keep developing the application. You can pay staff, you can pay your server fees, you can pay for your subject matter expert, you can keep exploring. So that is the new way most applications are deployed. Nobody wants to do an application, install it, collect a large chunk of money and go to bed. No, people want to develop an application, charge a little bit of money, but you keep paying either monthly, quarterly, or yearly. So that's how Oracle Boss, most of the banking apps you have, that's how they made most of their money. So because what's it called? The revenue is consistent. So you just grow your customer base. Then you have PaaS. So this is platform as a service. The question here is that what is going to help an engineer, a cloud practitioner, or a network engineer? What's going to help a developer? What's going to help a salesperson actually do his job? So it's like not just a regular application, but something that has more power, or like a platform that will help somebody do his job. So that's where you have platform. You see in the shared responsibility model, the person has the application, right? So the person controls the application. The person have like full power over the application, but the provider manages every other thing. But here you see that in SaaS, the provider manages everything from start to finish. You cannot say you want to tweak, you want to change, you want to adapt. No, you cannot do that. Everything is the responsibility of the provider, right? Like your Google applications, like even your operating system. You cannot say I want to change some things in my operating system. No. What you just do is that you pay for it and you update when you need to update. Your Zoom, for instance, your most of those applications, you just update. You cannot tweak, you cannot change. You don't have that power. But in PaaS, platform as a service, you have power to make some changes, right? Then you have some of the advantages and disadvantages here. Like you see, Heroku. Heroku is a service that most web developers use to develop the application, right? They have power to do a lot of things. Then for infrastructure as a service, which is this, so you see that you need to bring in your application, at times bring in your database, at times bring in a lot of things, and all of this is taken care of by the service provider. Okay, I think that's an awesome introduction to cloud computing, so I think we can move on. So having looked at an introduction to the different models, so we have IaaS, that's IaaS, I've already explained that. Who are the top providers? AWS, Azure, then Google Cloud. Then we have SaaS. Examples here, you just get the software and you are good to go. You pay subscription. So 365, FreshBook, Salesforce, Basecamp, you just pay subscription. So it's normally a cloud-based software licensing. So you don't do anything in terms of, you don't bring anything. You just pay for the subscription and you start using the software. Look at just what I explained a while ago. So you see, with your Google Docs, you can just sign in and you have a letter, you write it and you can email to somebody without any stress. Then PaaS, this is platform. So vendors, people can develop, deploy application all in a cloud environment. So you don't need to have the tech softwares. You don't have to have the whatever. You have like an environment. You see, you have like the, let's say HTML, let's say HTML, or let me say Python dev environment. environment, website work. Let me just Google this and see. Python anyway. So this is an example of a platform as a service. So if I click here, okay, they said it's $5 per month. I could start coding in Python. I don't need to install anything on my system. Another example is, I think when I code in Python, Anaconda Python anywhere. Let me see. Another good example is Colab. Google Colab is a classical example of Python, is a classical example of a platform as a service where I don't need to. I'm coming just a second. I don't need to have anything installed on my system, and I could start running Python codes. Okay, let me cancel this. Let me code, create a new file, new notebook. So if somebody is a data analyst, even on his PC at home, he doesn't need to have something installed. He could start import pandas as PD, import NumPy as NP. Then you could start doing some stuff. Let's say x equals to 5, y equals to 10, x times 25, 20. So ordinarily, I should have a software installed on my computer, right?
Yeah.
But I don't need to do that because this platform offers me that particular service. So this is an example of someone that is a coder, somebody wants to create an application, he wants to create a software. He could do most environments can give you can do you can program in most languages without having to have those softwares installed. I think I was training my students something on Tableau, and there's one of the students didn't have his computer was not compatible, couldn't do something or whatever. And right on the public Tableau environment, you can just click and you have exactly the same thing that you're going to have on your system. All you need to do is just to be online. That's an example of platform as a service. So you don't have any issues with servers, operating system, hardware. Are you there? So you just come in and do your stuff. Example is what? Cloud, Oracle Cloud platform, Microsoft Azure Salesforce platform. So you see language. Make sure the vendor selected supports the language used for development and server-side technologies that apps depend on. Most major PaaS vendors support most common languages. Like the one I just did now was Python. So Python, PHP, Ruby, Java, these are popular languages. And most of the times it can be, what is it called? Per hour or per month or whatever. Then you have another way you can classify, like we saw on ChatGPT, public, private, hybrid, and community. Public, anybody can use it. Private, maybe banks, institutions, healthcare. Hybrid, both of them. Community, more than one corporate organization or bank or whatever coming together to use one. So we've already explained public, private, hybrid, and communities. These are some of the more explanations if you need them. Now, cloud computing is a generic term that can encompass several different computer network models and features that serve a customer's unique requirements. This section describes different ways a computer cloud can be designed and implemented to meet the computing and network needs of a company or institution. You know, when people go to the cloud, when people go and they want to serve whatever they need to serve over the internet, it then means that they don't want the limitations that the local environment gives to them. And another thing is that they want to cut costs. So why do you need to do cloud computing? Like I said, costs. You want to get to market fast. So I could set up an S3 bucket and load in 10 terabytes today. AWS S3 pricing, right? I can even be on the free tier. So I have about how many terabytes free? I think it's about up to 50. Get set for free. Just a second. So your first US is how yes. Your first 50 terabyte per month is what? This. So that means if I have if I want to store 50 terabytes and it's frequently accessed, know there are different tiers. Let me not go into those details. 50 terabytes per month. So I have in 1 terabyte, I have 1,000. In 50, I have 5,000, right? So that I'll times by this. So in 1 terabyte, I have 1,000. In 50,
it's 50,000
times 50, that is 1,000 gig in 1,000 gig in 1 terabyte. So 50 will be 1,000 times 50, right? Times, we want to calculate how much we're going to spend. Times this. So just $1,150. And you start free. Now, this is per month. Now, if you are to configure this 50 terabyte on your physical system, oh boy, it then means that you need to get a computer, then get one that can be able to process that amount of information. Then tell me how you're going to stack 50 terabytes. Then you have to consider power, consider security, consider a lot of things before you set that up. But I can bet you, if you have 50 terabytes coming from different parts of the world and you want to upload it now, it then means that you can set it up now and you can open up for those people to upload all of those things and you start analyzing. Yeah. That's a huge advantage of cloud computing, faster time to market. You can spin up new instances. New instances refers to like machines, like a computer, or retire them in seconds when you no longer use them because you are paying per hour. Allowing developers to accelerate development with quick deployment, scalability and flexibility. So you can scale, you can say, okay, 50 is not enough for me. I want to go to 50, 500 terabytes. You cannot wake up one morning and say your computer in the office, you want to make it 500 terabytes.
That's too much.
Now, in doing that, your cost is becoming cheaper.
True.
So these are some of the advantages of course, cost saving, better collaboration. A lot of people can do things from different places. You give them access, you have more security, data loss prevention, because you see all of these things, they are durable. Durability will mean that if anything happens to them, you can get backups and you don't have any issues. That's why your hosting service is going to tell you that, okay, you lost your stuff. Okay, we have backup up till so date. Maybe pay this amount, or you have up to so date free. If you want if you want to go behind, you have to pay. So they are all tied to cloud computing because you see this deep archive. Yeah. It's for long-term storage. But anytime you want to get it, you need to give space of 12 hours, then you also pay, but it's far cheaper. So any data that has gone to a particular point, it will be moved to this particular storage. Cloud computing is a very nice concept that you want to explore following, especially for people that have interest in cybersecurity. So you have shared resources. That's one thing you need to understand about cloud computing. Internal cloud, you have external cloud, we explain most of those concepts. Then when we say elasticity, it then means that we can scale. These are the advantages of cloud computing. We can scale. We can say, okay, from 1 terabyte, we want to get 20 terabytes. And we don't need to be stranded. We don't need to be disappointed. But in our regular computing, where we have our systems with us and whatever, we cannot just wake up and say, okay, we need 50 terabytes. We have to really plan for it. We must have the space for it. We must have the money for it, right? And all of those other considerations. The high availability means that it's always available 24/7. And if we want to make some of these IT systems to be available 24/7 physically with us, we need to provide security for them. We need to provide backups for them. We need to also even mirror those storage devices and the rest. So that once one fails, the other can fail. Of course, for cloud computing, that's always taken care of. If one server crashes, this other server can pick up. So that is availability, right? And it can be replicated across different time zones, different geographical region. Fast synchronization. So that's possible. So you can sync between either your local, what's it called, service and your cloud service. On demand, it then means that you can demand for stuff only when you need them, right? You don't need to pay for what you don't need. You can subscribe for Salesforce for only 3 months. Your business is only 3 months.
Yeah.
You can subscribe for this Amazon stuff now for only 1 month. You just pay $1,100. You finish your job, you do everything, see how to back it up and whatever, and you shut down and you go your way. But if it is physical, that means you have to set up a server or series of servers tied together that can keep this stuff. Then once you are done with it, you have to now start looking for how to sell it.
Yeah.
So that's why it's on demand. Then metered utilization. So you only pay for what you use. So you can do pay as you go. You can do bulk purchasing. You can do tiered pricing. If you analyze the different pricing for, what was it called? For, let's use S3, Amazon S3. Amazon S3 is the storage service of AWS. So for this one, for instance, you see the different tiers. There's S3 standard. There's S3 intelligent tiering. There's S3 intelligent tiering. It has a little tweak. Then you have standard infrequent access. This infrequent access is when you want to store data that you're not going to be needing to retrieve every time. Then this is one zone. When you want to put it in one availability zone, infrequent access, then you have instant retrieval. Glacier is for storage that is typically archived. Then you have deep archive. When you want to keep something that you're not going to need, maybe like for a long time, maybe after 1 year. It's just like if you have a bank account and you don't use it for some time, most of your records are not going to be available on this tier. So customer service or your banking officials cannot just pull out your record. They'll have to tell you to write, apply. They will tell you to pay some amount of money to reactivate. So once you pay that amount of money, it can still keep it can still hit your account. But the thing is that your data is not going to be here again. That is easily, frequently accessed. Your data and your statement and your whatever is going to go deep down, right? It's going to go into archive.
Yeah.
So at times, you need to allow 24, 48 hours to get that data back. That data is always there. By compliance, by regulation, they cannot just delete data. But the thing is that the data is not going to be easily retrieved at a glance or just log in to see your details or whatever. That data will now go to another tier, right? So that's what we call the different tiering, pricing tiering. So you can pay for different types of service. So it makes it a whole lot cheaper. Let's talk about desktop virtualization. So I've already talked about it. If you have VMware, for instance, so this system, I have VMware here. I also have Oracle VirtualBox. So this is how it works. Virtualization. Let me use an image to explain it to you. So to do virtualization, you need a server hardware. So this is my system. This is my Windows 11 system. This is my VMware. Huh?
Yeah.
So server hardware, Windows 11, VMware, Oracle VirtualBox, Hyper-V. There are several of them. Top 5 virtualization softwares desktop, right? That is user end. So you have VirtualBox, see the logo. You have VMware, this is it here. So you have Fusion. Fusion is for maybe for Mac users that want to have. I think Windows users can also use it. You have Parallax. Most what's it called? Mac users will typically use this. You have Hyper-V. There are so many of them. Now, what they do for you is that you install them here. Once you install them, like I have here installed, it then means that this is it here. I can add different operating systems here. Like here, I just have Black Hat Linux and I have Kali Linux. So what will happen is that I could do a lot of things. I could browse, I could access my applications, but I'm still on one computer. So virtualization helps us to do quite a lot. We will not be able to do with just ourselves. So you see, this is the guest operating system. So we call this guest operating system. We call this host operating system. So, and in each of the guest operating system, like you see, I have different applications. See the applications running.
Those are the guest operating system.
No, this Kali is the guest operating system. These are the different apps inside the guest operating system. Yes. I could do Windows 7 or Windows XP or Windows 2000 here to test some items or to see some things or to test some vulnerabilities and the rest. So that is my guest operating system. So I can install things inside it that I cannot regularly install on my Windows 11, the host OS. So this is the host OS, the hypervisor, in my case, VMware, then Kali Linux, Windows XP, Mac, iOS, Mac OS, different operating system. Then you can have their apps. That is virtualization. So desktop virtualization refers to creating a user interface to a computer that is hosted on a central server on-premise or perhaps in the cloud. Either way, the user experience with the virtual desktop is the same. So companies use virtual desktop infrastructure. Users can use minimally powered devices with an internet connection and work as if processing were happening locally. Like in AWS, you could set up an instance and you can navigate into that instance like you have that system with you. You have some guys offering some of these services like Mac in the cloud. Let's say you don't have a Mac machine, right? And you want to rent it. So this is you having a Mac machine and you're just paying $25 for 1 month. Are you there? So you can buy anyone you want. Once you give $25 now, you have instant access into a 2023 MacBook. And you can typically do anything you want to do. If I check out now and pay, I have my MacBook in the cloud. All I need to have is what? Internet connection. Once I come online, I log in, I click in, I have a MacBook running on my Windows. So I can even tweak the configurations, right, of the MacBook. Which Mac do I want? Do I want the newest one, the Ventura 13.3, depending on the component? I have it in Xcode. Xcode is your development environment for Mac. Or if I'm used to developing in Visual Studio Code, not Visual Studio Code, Visual Studio, I can install Visual Studio. It's come pre-installed. Still different versions of whatever. Then you have the different, you want a mini silicon M2. You can have the latest. You want a 16 gig RAM. You just pay $5 additionally. You want to pay yearly. No yearly limits. So you just pay how much? If you want to use it 3 hours per day, then I want 16 gig RAM. I want 1 gigabit speed, so everything is going to be fast. I just paid $384 for 1 whole year, and I have access to a MacBook. So if I'm a developer, I cannot afford a MacBook now. With $384, I could get one. The latest, for that matter.
Run it from your Windows.
And I access it from my Windows.
Wow.
So you can access this through client software called installed on your local device or via web browser. So desktop virtualization is also called thin client networking because the processing is centralized, right? So you see these guys now, they are all using my own processor. They are all using my own hard drive. Like you're going to see that if I want to use this stuff, for instance, right? Let me sign out. Let me just shut down this machine. Let me shut down. So if I shut down this machine, you see that each of the operating system I have here, I could decide what I want. This system I run now, this particular system I'm working on now is a 20 gig, has a 20 gig RAM. So I can assign 12 gig to it, assign processor speed. I can say, okay, no, I want to assign, what was it called? I want to assign power general, power guests. Just a second. Edit virtual machine settings. Okay, you can say the memory, it's 12 gig. I want to make it 13, right? You can just say, I want to give it 16 gig. Then you can say, okay, the processor, I want to increase it. The hard disk, 80 gig, because this 80 gig now is going to be 80 gig for only this Kali Linux. Are you there? It's going to be for only this Kali Linux. So I cannot do more than 80 gig within this environment. But this system I'm working on now is a 1 terabyte machine. So I'm giving only 80 gig. If I want to increase it, I'm trying to see how, I don't know. Just a second. Is it because I've already configured before now? Edit. Is it because, I'm sure this guy is shut down already. Edit virtual machine. So I could actually increase, okay, look at it here. Memory, hard disks. It's not allowing me to, I think maybe because of the initial setup, if I took this, it might affect some things. But for the RAM, I think I can change this RAM. I could increase this RAM, I could decrease it, right? Could keep it at 8 gig, put it at 16 gig, right? And automatically it's going to become 8 gig. It was 12 gig before. Yeah. So you see, all of this stuff now is tied to the host PC. Are we together? They all share the host machine is going to assign IP address and the rest to them. Okay, so you have some vendors, which is Hyper-V, Oracle VirtualBox, VMware, Parallels. So these are different. Okay, so what else again? A computer can run different operating systems in 2 ways, virtualization or emulation, right? So we can also say 3 ways. Okay, maybe 2 ways, because we're talking about different operating system. You know, Okay, we can also say 3 ways. We can triple or dual boot in the sense that we want to install the additional operating system on the device itself. That means once we start up the system, we want to be able to boot from, we choose which operating system we want to boot. That's one way to do it. Another way is that we're going to virtualize. That means we install VMware or any other software. Then we add the new operating system on top of it. Then another way is that we're going to do emulation. Is that we just install a software that can help us run it like we are, what was it called? It's just like somebody had a software. What's the name of that software that you can use to emulate mobile apps? So you can install it on your system. Then you can be installing those Android applications and test how they look like without you typically installing them on your mobile phone. Okay. So this is also what I explained earlier on. This is Oracle VirtualBox. I think for my own Oracle VirtualBox, let me load it up. So this guy has Microsoft Windows 8, Windows 8.1, Windows 8.1 install clone. That is this guy now, he duplicated it. Then he has Ubuntu, then you have Windows 10. So you see that you can run multiple, operating system inside one machine. I think this is my Oracle VirtualBox. I have not done any configuration. I think I'll typically use this for the CyberOps machine. So if I want to add a machine now, all I just need to do is to import or add. I need to put in the image. Once I put in the image, and it's going to install. I complete the installation. I'm going to have it as 1. I add again 2, add again 3. Anytime I want to access any of those operating systems, I just open my Oracle VirtualBox, click on it, and I'm inside that particular environment. That's what you call virtualization. Question is, why do you need to virtualize? Common use of virtualization is sandboxing. I explained that when you want to separate your concerns, if there's a software that you might think has some risks, or is not working on a particular operating system, or you want to test for vulnerabilities, or you want to just check some stuffs, right? You can now move them into that environment and you do all of the testing that you need to do. You want to test development. You want to do application virtualization for programmers. You want to do cross-platform compatibility check, right? Another thing is that if cross-platform version is a type of application version that can involve different underlying virtualization technologies. For example, the virtual software Microsoft 365 can run across platforms as well as operating systems such as iPad. So this is just an application that's going to be able to run on any of those operating systems. Then legacy software and operating system. You see some softwares that cannot run on, let's say, cannot run on so you have, this is 64-bit. What about if I have a software that cannot run on 64-bit? What do I do? Cannot run on 64-bit Windows 11. What do I do? So virtualization can help me so that I'm going to put those softwares there and of course test. So with virtualization, I could run a single PC to run both 32, 64-bit with the same operating system. Okay, so resource requirements. Now, a workstation that will be used for virtualization needs to be designed with fast multi-core processors. You cannot say you want to do virtualization and your system is 2 gig RAM. Your system is 4 gig RAM. Your system is 8 gig RAM. You're going to have issues. My advice normally, if you want to do virtualization, you should be running at least from 16 gig, 20 gig, 24, 32 gig, 64 gig, 1 to 8 gig. you should have enough of resources, right? Because now you want to share. Can you share what is not shareable?
Oh.
Can you share what is not shareable? So you need a lot of resources. Just understand, if you need to virtualize, you need resources, right? And you must enable virtualization in your BIOS or UEFI. Because once it's not enabled, virtualization will not work, right?
Okay.
Enable virtualization. This is a Lenovo, I use a Lenovo IdeaPad, I think 14 something. Right there. So every system have a way to access it. So you just say, you go to security. Okay, I think this is a tutorial. Okay, look at it here. Yes, so, support for virtualization. So it has to be enabled. If it's not enabled, you can install a VMware, but you're not able to import an appliance. You will not be able to import an operating system on your software. It will tell you that, to just pick some grammars to you, tell you virtualization not supported. What do you need to do? You go to BIOS, you come to this place and enable it. Different systems have it differently, right?
Yeah.
Security, virtualization, tap on it, click on it, then your next environment, you enable it. If it's for HP, yes, let's say HP gaming, HP gaming PC, how do you do it? You go to security, system security, virtualization, you enable it, right? Look at this one. You go to, where's virtualization here? Look at it, virtualization here, technology. So you go to virtual, you make sure it is enabled. How do you select it? You press your plus minus. Plus or minus is going to toggle enable and disabled. So once you tap press plus minus or page up, page down, depending on your keyboard, it's going to turn on. So it's until this is enabled that you can do virtualization. So some recommendations, make sure you have at least minimum 1.3 gigahertz, but I would typically say at least 2 gigahertz. Then 4 gig, I would typically say at least from, let's say, depending on your budget, from 8 gig above. So each of these softwares will normally have their recommendations. So security requirements, network traffic monitoring, VM backups, updates and patches, security, best security practice for VMware, important and little tips that you can read up. Okay, so some of the key terms we looked at is IaaS, SaaS, PaaS, public cloud computing, hybrid cloud computing, private, community shared, mental utilization, rapid elasticity. That's to say that we can scale, we can increase, we can actually improve our whatever we have, either space or infrastructure. Okay, let me know if you have any questions. There are some questions here you can find time to answer.
No question.
So these are some nice questions you can answer. I think next we're going to be looking at hardware and network troubleshooting.